In the first video for this Module 6, we talked about just things that kind of set the stage for giving you background information about thinking about growth in equity. Here, we're going to talk about growth formulas, and these are going to give you specific ways to measure growth and predict what your growth is going to be in the future and the factors that are affecting that. We'll first start with a formula for growth, and then we're going to add in risk from the return on assets, and then finally we're going to add in risk from both return on assets and interest rate risk. And as we do that, our formulas just get a little bit more complex. So first of all, our formula for growth. The growth of equity formula, G, is equal to the growth of equity, this is our rate of growth, is equal to the return on assets times the assets over equity, minus the cost of debt times the debt over equity. And this whole thing here, this first part, is really our return, the profit that we're making. We multiply that by 1 minus the tax rate to give us an after-tax return. So after we pay the government what we have left, and then we multiply that by 1 minus consumption to give us really what is retained in our business. Because if we consume it and we withdraw it from the business, then it's, even though we made returns, it's not growing our equity. So the only thing that grows our equity is the amount that we keep in the business. So that's 1 minus the consumption. These formulas are also available on the handout. And these are just explaining what the different parts of the formula mean. So let's do an example. And this corresponds to page 170 in your textbook. So we have a situation where return on farm assets are 16%, the interest rate is 12%, the tax rate is 20%, and consumption is 50%. So we have two situations. Each farmer has $1,000 of equity capital. However, farmer C has a debt to equity ratio of 0.5, which means 50 cents of debt for every dollar of equity. And farmer D has a debt to equity ratio of 1. $1 of debt to $1 of equity. So farmer D is more highly leveraged than farmer C. Here's our growth formula again. So R, the return on assets, times the assets to over equity minus the interest rate times the debt over equity, 1 minus the tax rate, 1 minus consumption. So for farmer C, the return on assets is going to be 16% times the assets over equity. Here, we know that their debt over equity is 0.5, and assets over equity is always going to just be 1 more than that, so it's 1.5. And then minus 12% interest rate times 0.5, their debt to equity. This whole thing will be their return. Multiplying it by 1 minus the tax rate gives us the after-tax return. In this case, the tax rate is 20%. And then multiplying it by 1 minus 0.5, the consumption rate, 0.5%, gives us the net returns, or the growth in equity. As I multiply that out, 0.16 times 1.5 gives us 0.24, minus 0.06 is the 0.12 times 0.5, 0.8, 0.5. Keep figuring it out. Our G is going to equal to 0.118. So this 0.118 is the return. You're making 18% return above your interest, but we're only keeping 40% of that. This 0.4 is equal to the 1 minus the tax rate times the 1 minus the consumption rate. And so this whole thing together can also be considered K, and it's the percent you're keeping. So in this case, we're keeping 40%. And we multiply that out. Our growth rate is 0.072, or 7.2%. So with $1,000 of equity capital, the retained earnings are going to be $7,200, or $1,000 times 0.072. So that was for farmer C with 0.5 debt to equity ratio. And now if we do it for farmer D, their growth rate formula here, The same thing, 0.16 times 2, but now instead of 1.5, we're timesing it by 2, and the interest rate we're going to multiply by 1 for our debt to equity ratio. This part is still the same. And so in this case, we're getting 20% as a return, and multiply by that 40% that we're keeping, or 0.4. And so our expected growth rate here is 8%. The retained earnings will be $8,000, $100,000 times 8%, where before for Farmer C it was $7,200. So everything is the same here, the same return on assets, the same interest rate, tax rate, consumption rate. The thing that's different here is the leverage choice. And so Farmer D has more leverage, more debt than Farmer C. And so in this case, because that return on assets is greater than the interest rate, then higher leverage means higher growth. 7.2% versus 8% down here. Here on page 171, there's a table that shows, based upon 50% consumption, 20% tax rate, and an interest rate of 12%. For various leverage choices and return on asset rates, it shows the different amounts that you'd have for a growth rate. These are percentages. So I think one of the interesting things to look at here is at 0.5 leverage. So that means 50 cents worth of debt for $1 worth of equity. As where return on assets goes from 4% to 25%, we're going from 0 to 12%. So there's about a 12% range there. With very high leverage down here at a 5, so $5 of debt versus $1 of equity, we're going from negative 14 up to a positive 36. So there's about a 50% spread there. And so one thing to realize is, as your leverage is getting bigger, you're going down here, that you're getting a wider range, and that means that we're having more risk that we're taking on. And in fact, even at a leverage of 1, which is $1 of debt versus $1 of equity, if your return on assets is 4%, you're going to have a negative growth. So your wealth is actually going to go down by 1.6%. And so I think that, and then as you get more and more leverage, you'll see those negative options becoming bigger and more prevalent. So there's risk are involved here. And so that's sometimes why we call leverage as a double-edged sword. In favorable times, higher leverage can stimulate growth. But in unfavorable times, it can cause businesses to deteriorate rapidly. So as long as you have more return on assets over your cost of your debt, leverage is helpful to increase growth. But if something happens, you have a drought, the markets go down, you get a disease, something like that, severe weather issues, in unfavorable times, that higher leverage can cause you to have even higher economic issues with your business, and you can actually deteriorate your business and wealth can decrease. Sometimes we've heard the term, the bigger they are, the faster they fall. Or in this case, the more leverage they have, the faster they fall. But also they have the chance to increase their equity too. So in ag, it's unusual to see a higher debt to equity ratio than a 1 to 2 range. And a lot of times it's actually not higher than the 1. In other businesses that don't face all the risks that agriculture does, you may see much higher debt to equity ratios. So leverage and risk. With higher levels of leverage, the changes in growth from changes in any of the variables are bigger. So it's important, the stakes are higher. So it's important to not only understand the level of growth, this is the expected level of growth. We don't know exactly what it's going to be. This is just what we expect because we're looking into the future to make decisions. So it's important to understand risk. So we're going to talk about 2 different levels of risk. The first situation is risk only on our return on assets. We have fixed interest rates. And then the second situation says not only does our return on assets have risk, but our interest rate may also go up and down. So this is example C again, only now we're going to add in return on asset risk. Same situation, only now we've added in the standard deviation of R, or the standard deviation of your return on assets, is 6%. Still the same growth formula, and still the same way to analyze the growth. Only now, this is saying we know exactly what the growth is, and we know what all these other things are. The truth is we don't know that. And so this bar that we put in here above the return on assets says that that's the expected return on assets, but not the actual. And then that's going to cause, since we're using expected return on assets, we're getting an expected growth rate. And so all of these should have bars above them saying that that's the expected growth. The formula as far as the variables haven't changed. So what's changed now is that we're using expected values for one or more of these variables, and so we're getting an expected growth rate and not an actual growth rate.